Okay, the third one is on patterns. So actually there are a lot of patterns, not only on design pattern. We also have requirements pattern and others. Okay, but in this part we are focusing on design. Okay, so again it is a repeatable solution. That means something that you can reuse. Okay, to a commonly occurring problem in software design. So when you have this problem and when you check, it is also common in other design of other systems. Okay, perhaps you can have a look at the design pattern if there is any relevant pattern that you can adopt. Okay, so a design pattern is not a complete design, okay, that you can directly transform into code. Okay, so normally they will just give you like a framework or the pattern information, okay, and a description of how you can use it, what are the things that you should be aware of. Okay, so it's like a documented documented material for you to refer. Okay, so what are the advantages of having patterns? So first, it can speed up the development process, because whatever pattern that you choose, it has been tested, it has been proven that it works in that particular solution. Okay, and it does not tie to a specific implementation or specific platform or specific language. So you can have multiple implementation in different platform or languages. So that means it can be reused. Okay, so what you have to know is to understand the pattern, whether it is suitable for you to adopt or not. Then you look at their recommended guideline, and maybe they also have some samples. Okay, so it allows the developers to communicate using well-known solutions, because developers can discuss at a level where it has been implemented, rather than being vague about the discussion. Okay, so normally when we talk about the design pattern, they will have this like template, okay, things that will describe about the pattern. Okay, first is the name, the intent, what is the purpose of the pattern, and what can the pattern do. So other names or synonyms of the pattern, and what is the motivation of the pattern, and the applicability of the pattern. Okay, so I tried not to be too technical, and I tried to explain so that everyone can understand the concept of design pattern here. Okay, so the first one is the types of design pattern. There are three types. Okay, these are the common three types defined by most of the authors. Okay, so one is the structural design pattern. Okay, and the second one is creational design pattern, and also the third one is behavioral design pattern. Okay, so the differences between these three categories of design pattern. The first, structural design pattern, are related to compositions of classes and objects. So all these examples, adapters, bridge, composite, decorator, facade, flyweight, private, class data, proxies, these are only examples. There are hundreds of design patterns. Okay, so these are all design patterns that can solve the problems that are related to class and object composition. Okay, and the second one are related to creation of classes or objects. Okay, that means if your problem is related, anything related to the creation of classes or objects, so you can refer to this category of design pattern. And the third one is the behavioral, which involves the responsibilities between objects. Okay, so it can be the chain of responsibility, or it can be in terms of command, interpreter, iterator, mediator. So these are some of the example. Okay, so I will pick one from this to explain further what is actually a design pattern. Okay, So this is another source to show the types or the examples of design patterns based on the category. Okay, so it has a brief description about each of the design pattern. Okay, so I think this is just an additional information. So we have the creational, like here if we say factory method provides an interface for creating objects in a superclass but allows subclasses to alter the type of objects that will be created. So this is the definition of the purpose of the design pattern. Okay, so they also have design patterns for behavioral pattern. Okay, I think the common one that you might have heard of is the iterator design pattern. Okay, now I want to give you an example that is taken from this website. You can read through this website for a much more detailed explanation. So I just want to explain at a level that I think everyone can understand the concept of design pattern. Okay, so first is what is the problem, okay, that can be covered by the design pattern. Okay, for example, you are working on a logistic management app. Okay, so the current solution that you have only handle one type of transportation. So maybe at that time when you started, it only covers one type of transportation, which is the trucks. Okay, so right now the logistic has expanded to have other types of logistics which are coming from the sea. Okay, so right now you only cover the road logistics. Okay, so then your logistic app, okay, currently is only focusing on the road logistics. So when you have other types of transportation, then your apps cannot handle the additional transportation type. Okay, so the solution is that you can adopt the factory method design pattern that suggests you the solution. Okay, so the solution is of course closely related to the implementation. Okay, but those who have taken object-oriented programming, they might relate to the solution. Okay, so the factory method suggests a way that you can do in order for you to create new objects to cover the other C logistic platform. Okay, so that's the idea. So in the representation, you can now have the logistic, and you have the road logistic and C logistic to inherit from the logistic class. Okay, so whenever you create let's say an object of the transport, for example, okay, when you create an object, you can create either as a road logistic or C logistic to cover different transportation type. Okay, so now the solution represented by the factory method is to have an interface of a transport class, so that you can have a method deliver that can have different that can allow the subclasses to override from the superclass. Okay, that means the deliver by the truck is going to use a different implementation, and the deliver process that is going to be sent by the C logistic will be using a different implementation, but they are all using the same deliver function. Okay, so that is what recommended by the factory method. So as a result of that, because of the organization of the structure. Okay, so now you can see that by using the transport from the transport class, the instances from the transport can be different, okay, according to the types of logistics. So if they are C, they will be calling the same name, but the implementation will be different according to the transportation type. Okay, so that is what you can do by using or applying the factory method. So what does the factory method looks like? So this is the pattern. Okay, so there is a creator and there is like a subclass. Okay, so you have a creator and you have like one method in the superclass, which represent the instances of the subclasses. Instead of having this structure, you can use this structure. Okay, so by using this structure, if you declare it as an interface class, that means it can override, it can allow the subclasses to override from the superclass. Okay, so this is actually what they call it as the factory method. Okay, so in order for you to adopt the design pattern, you have to at least have some knowledge of existing patterns in order for you to know which pattern that can solve your problem, right? So that is, I hope at least you have some kind of understanding in terms of the design pattern. Okay, then we have the separation of concern. Okay, separation of concern can make a complex problem to become much more easier to manage. Okay, so that is the idea, right? And another way is in terms of the data and in terms of the modules, you can use the concept of modularity, so to make sure that the coding part can be manageable. Okay, so you imagine like if you are currently taking EOP. Okay, so you have the function, the main function. You write everything in the main function from the beginning until the end. Okay, so it's not modular. Okay, if it is modular, then it should be broken down into smaller pieces so that it is much more easier to understand and much more easier to handle. Okay, so that is the modularity concept. In terms of information hiding, so you can have whatever, as I mentioned just now, whatever you want to hide from others. So you allow them to have only the interface. If they want to know anything, they have to go through the interface to get some information that is allowed for them to access. Okay, so there are many reasons why information hiding is recommended. So the first one is that we want to reduce the effect, okay, of the changes that is not relevant, okay, to be allowed to unauthorized access. Okay, and then we want to limit the impact of the global impact of local design decision. That means if you change something from this part, okay, you don't want it to give any other external impact to other parts of the system. Okay, and it can also emphasize communication through the interface. So anyone who would like to get access to some relevant data, you can just get it from the interface. Discourages the use of global data. Okay, so global data sometimes you need it, but try as much as possible to reduce it. Okay, because it gives an impact to the whole system. Okay, leads to encapsulation. Encapsulation is also a property of object-oriented. Okay, which means that when you encapsulate, actually you are supporting the information hiding. Okay, so when you say a class actually encapsulate attributes and its states or its behavior, that means a class is actually supporting the information hiding concept, okay, and this can lead to higher quality software. Okay, so the next one is on stepwise refinement. So this is an example from the procedure abstraction just now when the door is open. Okay, what actually the refinement of the open process. Okay, so you open the door, which you have to do these steps. Okay, and these are the refinement from open door. So this is just an analogy. Okay, so another thing is that when you look into modules, okay, some people may have different views on it. Okay, some may look into the size, okay, or some may look into the complexity, or may look into the function. What does this module do? Okay, so different views may have different ways into looking some perspectives. Okay, next is functional independence. So I already mentioned just now, so now I want to recap on these two important concepts. In any course, if you are dealing with design, these two concepts are very important. Okay, so first is cohesion. Cohesion means that the functional strength, okay, of a particular component. So if you are talking about a function, whether it is cohesive or not. Okay, so when we say cohesive, means that it only performs single task. Okay, and it is not dependent to other parts, or little or less dependency to other parts. Okay, when we say coupling, means that the interdependence between the elements or modules or functions. Okay, so the coupling depends on the interface complexity between modules, okay, and the data passed across the modules. So coupling, we want our design to be low coupled. Okay, and in terms of cohesion, we want our design to be highly cohesive. Okay, so that is what we aim for. High cohesive and low coupling. Okay, so that is the recommended design property. So in terms of aspects, okay, the aspects can be cross-cutting concerns. Okay, so when you have two or more concerns, so you call it as an aspect. Okay, so there are some paradigms that are working on aspects oriented. Okay, here you can see that the two requirements, they can cross-cut each other's. Okay, because one is talking about having access to the camera surveillance via the internet. Another one is saying that all registered users must be authorized in order to use the system. Okay, so these two can actually cut their concerns. Okay, so we say that requirements B, which means that the user need to authorize first before they use the system, can cross cut the requirement A. Okay, so that is in terms of mostly these concepts of aspects are used for quality features. Okay, like security, performance, availability. Okay, not so much of functional properties. Okay, next is on refactoring. So refactoring means you want to change the structure of your system in a way that it does not change the external behavior of the code. Okay, but improve the internal structure. Okay, for example, if you use Google search, for example, okay, so let's say Google decide to improve their internal structure, like they want to change their algorithm to improve performance, improve accuracy of the results, and so on. When they change, as a user, we cannot see any difference. Okay, we access the same URL to the search and we input our text to search as usual. Okay, but we don't know what has actually been changed in the internal structure. So that is what they meant by it does not alter the external behavior of the code. So from the user side, we can still access it the same way, but actually it has been improved. Okay, so what can refactoring do? Okay, first maybe there are some codes that are redundant that needs to be removed. Okay, or there are unused design elements, or there is inefficient or unnecessary algorithms, or poor or inappropriate data structures. So they want to change data structures to make it much more efficient, or any design failure that can be updated to result to a better design. Okay. Then on inheritance design concept, there are a few that I've mentioned just now, so we're going to go through faster. Okay, but this one, when we move from analysis to design, okay, so we want to refine the design of the classes that we have. Okay, so for example, before this, you have these classes. Okay, maybe you don't mention or you don't specify the data type. So now in design phase, you're gonna refine the class by providing the data type, the return type, the parameters, the argument. Okay, so those are some of the steps that we do in design in terms of refining the design. And in addition to that, we also need to classify these classes into either one of these. Okay, boundary or controller or persistent classes. So boundary interface classes, controller processing part, and the persistent classes are the entities or the data storage. Okay. So from here we have the ATM form, we have the control here and the bank database. So you can see that ATM form is actually the interface stereotypes. Then we have the controller, which manage the input from the interface, and they access the information or the data from the persistent classes like the entity, and also they will pass it back to the ATM to the interface class. Okay, so these are some of the things that we do in terms of refining design classes. Okay, so ideally this is a recommended design tips, because we don't allow the interface to interact directly to the persistent classes. Why? Because by having an intermediate controller class like this, okay, you can avoid any issues in terms of unauthorized access, or you can first verify any changes before you display or before you store into the database. Okay. Another alternative UML notation to represent the design classes. Okay, for interface, they use this notation to represent the boundary classes, controller to represent this notation with an arrow, a circle to represent the controller part, and the entity with one line at the bottom to represent the persistent notation. Okay, okay, so have a look at this class diagram. Okay, which one is the boundary or interface class, and which one is the controller, or which one is the entity classes? Okay, so let me know. Alright, so design classes, we want them to be complete, and then we want them to have high in terms of functional dependencies or primitiveness, and high in terms of cohesion, and also low in terms of dependencies between classes. Okay, or we say low coupling. Right? So you can read further on architectural design elements, component level design, interface design elements in the respective chapters of the textbook. Okay. So lastly, we're going to look at the design models. Okay, so in requirements engineering, we are focusing on the analysis model at the top part of the figure right now. Okay, so from this analysis model, which is more abstract, okay, so we further refine it to much more detail in the design model. So these are all the expected the model to be produced during design stage. Okay, so and you can see some of these analysis model, they are also duplicated at the design model, but what they meant is that they will be refined. Okay, that means they will be further detailed out in the design stage. Okay, so for example, if you have design class diagram, okay, it will be design classes. It will be further detailed in the respective process dimensions. Okay, so this will explain the diagram just now. Okay, so we have the data modeling. So these are all related to data objects. Okay, anything that you store information and you represent that in terms of data modeling. Okay, so data modeling represent any collection of information that needs to be stored by your solution. Okay, so that is the data part. Okay, so for data objects, okay, so when I say objects, okay, it's not a class. Okay, so it represents a set of attributes. Okay, for example, we have, let's say, automobile. Okay, what are the attributes that are relevant for you to abstract in relation to your solution? Okay, so perhaps make, model, body type, price, and some options. Okay, so what about if you're talking about specific book or specific students? What are the attributes that are relevant? Okay, then we have the relationship between the objects. Okay, so for example, between a person and a car, if a person owns a car, so the owns is actually a relationship. Okay, and in terms of architectural elements, okay, so there are derived from three sources. One is information about the domain, okay, the where your solution will be applied to. Second one is the requirements model elements, okay, so all the models that you provide. And the third one is the architectural patterns. Now we look into architectural patterns. So this is an example of architectural diagram where you can see all the code elements of the structure of the system. So it's connected to a control panel, connected to the internet, civilian function, sensors. Okay, so this is what you expect to see in an architectural diagram. Okay, so in UML, they also have this component structure to show the components that are related to the system in terms of components. Okay, so architectural styles, we're going to see a few examples of architectural styles. Okay, quickly. Okay, for example, data-centered architecture. So this the significant property of this architecture is that the data or the storage or the database or repository is the central focus of the architecture. So anyone or any client will get to access to the data store. Okay, so this concept, sometimes they also call it as blackboard mechanism. Okay, so the processes are independently executed by the client components. I mean, client component compute the processes on its own. That means you need to have the client to install the application. Okay, the second type is the data flow architecture. So you have the concept of pipe and filter. So you get some data, then you filter, then you pipe to the next filter, and you further do the same processes either in sequential, or you have pipes and filters as connected through a series of pipes. Okay, So that is an example of data flow architecture. And we have the core and return architecture. Okay, so these programs, you have many sub-programs or sub-components. So the main program will call and will invoke any modules and return the result to the caller. So this is commonly used as well. Okay, and we also have layered architecture. So you have the inner layer through the user interface layer. So this is where the user will interact with the system. So the user will not directly be able to access the core layer. Okay, so there are certain types that requires these respective different types of architecture. Okay, then we move on, instead of architecture, we move on to the interface element. So interface element is not only the interface design that you see in coming out with the user interface design, but it can also be interfacing to other gadgets or other interface sensors, inputs, okay, like keypads. Okay, so that can also be an interface element. So when we learn about interface, we also will cover a bit on interface design, and you will learn further in KCI course later. So we just have to use at least some basic elements so that you can further cover it in other course later on. Okay. So some of typical design errors are inconsistent. Okay. Too much memorization. Your system somehow require the user to memorize certain things in order to go about your system. You don't provide any help or assistance, not sensitive in terms of the context, and poor response or unfriendly. So these are some of the typical design error. Okay. And other designs issues are related to response time, the help function, error handling, labeling in terms of your navigation, okay, accessibility, and also in terms of internalization. So now for designing interface for web and mobile app, so you are recommended to look into the user's perspective, okay, whether they know where they are, okay, in terms of the hierarchy or location of the system. What can they do with the system? Like what functions are available, okay, what content is relevant, and where to go next from here. So those are some of the things that you should consider. So in terms of the interface design principles, there are like more than 10 interface design principles where you will do an exercise on this as well for this topic. Okay, so basically I'll just choose a few of them. Okay, for example, when you say communication, okay, the interface should provide communication status, okay, of any interaction between the user and the system. For example, if you have any error, the system should communicate to tell the user there is an error and what are the ways to fix it. Okay, and if let's say you are filling in a form, okay, you have to communicate in terms of what are the things that they should know. Okay, the next one is consistency. Okay, so this is important for user interface design, that your you use consistent design elements. Okay, for example, in terms of your themes, in terms of your the way you organize your navigation, your menus, your buttons, your icons. Okay, the look and the feel must be consistent, especially when you are working in a professional context. Okay, like you are building solution for organization. Okay, so they have some standards that you have to follow. Okay, so because you will explore this in your exercise later on, so I'm gonna just go through and and choose a few of this. Okay, learnability. Okay, that means that the design that you pick should reduce or minimize the learning time. Okay, and once they have understood how it works, then they don't need to relearn when they come back and revisit your system. Okay. Next one, like visible navigation. That means that you try to provide a way that they can really aware of where they are right now. Okay, so you can use different mechanism to achieve those design principles. Okay, so in terms of the recommended workflow for interface design, okay, it is recommended that we review the information from the previous analysis model, especially the use case specification, and refine as required. And we kind of draft the user interface, okay, through the relevant prototyping or user interface tools, and then try to relate with the user needs or user task in the system. Okay, and provide the storyboard screen images for each interface action that can be done through the tools. Okay, and further refine the layout from the input from the stakeholders. Okay, so for example, you can have this kind of mapping, okay, to map the interface with the user objectives. Okay, and then what else? Okay, so define the user interface objects that are required to implement the interface. For example, if you are to design a form, what is the best or the most efficient interface elements to interact with the system? Is it a radio button? Is it a chat box? Is it a text field? Okay, so as much as possible, you want to reduce error or minimize the effort from your user. Okay, remember that we are dealing with taking input from user and displaying output to user. So what is the best element that we can use to get input from user and to display output to the user? So it depends on what kind of information that you want to get from user. So is it something that is definite? Okay, then you have to provide like a menu option, so you don't need them to type. Okay, so these are some of the steps that we can do to come out with interface design. Okay, so in terms of the look and the feel of the interface, okay, so there are many tips on this, okay, but basically they are consistent with the principles that you have heard before this. Okay, for example, in terms of the consistency, okay, in terms of the organization. Okay, so those are some of the tips. Okay, component elements. So these component elements describe the internal detail of each software component. So it can be in terms of the data structure, in terms of the algorithm, in terms of the interface. Okay. So in UML, we can use component diagrams, even activity diagram, okay, to represent this internal component element. So some of the recommended design principles for component as recommended by Martin in Design Principles and Design Pattern, they have some principles that can be used as a guidance, okay, in order to design components. Okay, so for a mobile web or web app, okay, so there is a concept on the thin or rich client, or some of them use the term thick, okay, thin and thick. Some use the term thin and rich client. Okay, so the difference between this is that the thin client only the interface layer is on the device. Okay, I have a diagram in the following slides. Okay, the business and data layers are in the server or in the cloud. Okay, but the thick clients, they have the application part, the logic part runs on the client software. That means it has to be implemented, it has to be installed, or it has to be in the client. and it can be limited based on the configuration of the mobile devices. And there is also a new trend on zero clients. That means you don't need to install anything. This is also a new direction. Okay, so the traditional versus the thin client architecture. Okay, so the traditional here is the thick or the rich client. So the rich client means you have to install on your client, they're connected to the server, okay, or the internet to get access to the server, okay. And the thin client means that you don't need to install it. It will be mostly covered in the server side, okay, or the cloud side, okay. So the server handles all the processing, but here the processing happens on the local device, okay, only to get data from here, pass it here, and the processes will be handled at the client, okay. So how we can use UML to represent these components? So we can use this component diagram. So we have, this is a component, we have the port, okay, the services provided and required. So this is the dependency to another component or module, okay. So this is another example where you have to read from the sensor, okay. So that is you need the data from the sensor, and the sensor management will do the processing, okay. So then we have the last one is on deployment, okay. So deployment is representing the system or the subsystem in terms of the physical computing environment, okay. So the representation can be used can be done using the deployment diagram. So this is a UML deployment diagram. So this is one physical element, okay, that shows that this personal computer and the control panel and the CPI server are not running in the same physical element, okay. So you can also have this separation of physical elements and represented in deployment diagram, okay. So as a summary, we have looked into some introduction on software design, good guidelines of good design, some quality design principles, and also fundamental design concept, and also some design models, okay. So this is only like an overview of software design. We will learn further detail in systems analysis and design for KICT students. For the rest, if you are interested to know further, you can find tutorials on software design, okay. So with that, we end the lesson. Assalamualaikum and thank you.